Welcome to this Swordfish 3D tutorial. First of all, when Swordfish is open, we go to the options and set the units to millimeters with a precision of 0.2. Here we have an hull surface I have imported from my files. To load it into Swordfish, we go to the panel on the right. Here we can assign a name to the model, in this case Test01, and then choose the import type. The import options are half starboard surface and closed poly surface. We select half starboard surface, then click Load Geometries. At this point, we can verify that the geometry has been imported correctly. By clicking in the dialog panel on the different display icons, we can see what Swordfish generates starting from our surface. If the surfaces and solids have been read correctly, we will see the message SF hull is valid. Here we can also generate and visualize the sections that will be used for calculations. Now let's look at a second import case useful when we have a hull with appendages. In this case, it is important that all appendages are closed solids, and the same applies to the hull, which must be complete with deck, bow, and stern closed. We select closed poly surface, give the model a name, and load the geometry. If the diagnostic message is valid, we can proceed with generating the sections. These are the sections of our model. One fundamental point. When we have more closed surfaces, such as appendages, these must intersect the hull. Swordfish works on Boolean operations, so a real geometric overlap between appendages and hull is required. Now let's look at the settings. In the settings, we can define water density, the number of decimals for each value, how many sections we want to generate, and the volume and distance tolerances used for balance and stability calculations. Here we can also define the maximum number of iterations for balance and stability, but the default values work very well. Then we find the units, and finally for each type of analysis, we can choose which data to display. If we want, we can save these settings as default, so every time we reopen Swordfish, they are already set. Now let's go back to the previous hull and move on to load cases. In the load cases panel, we can add different cases. We find the design load case, DWLC, where weight and center of gravity represent the condition defined by the design. Of course, we can modify the values, add new cases, delete them, and also save a library of load cases. We can also visualize the points related to the center of gravity. Here I create a new example case that we will use later to show the stability module. Load cases can be exported as JSON files, saved on the computer, and re-imported at any time. Now let's open the Design Grid module. This is the classic hull design grid. We have sections, buttock lines, and water lines. We can modify their number and spacing, have more or fewer of them, and display them only on starboard, port, or full. We can split them with respect to the center line, change colors, and in the advanced options, we can display curvature graphs, which I will not show in this tutorial for simplicity. With Bake to Rhino, we can bring the design grid into Rhino and obtain a lines plan ready to be laid out and printed. Now let's move on to the Hydrostatics module. Here we can choose between two approaches: a method that directly uses the BREP surface to calculate hydrostatic data, or a method based on sections. If the sections do not exist yet, they are generated on the fly. Otherwise, the already generated ones are used. In the diagnostic panel, we find the main hydrostatic data. We can also generate sectional curves, which allow us to calculate and visualize parameters that explicitly require them, such as the prismatic coefficient. One very important aspect is that hydrostatics is live. If we modify the geometry, for example, by moving the control points of the surface, Swordfish recalculates automatically. As a result, when working in BREP-based mode, the feedback is extremely fast and becomes very useful during the hull modeling phase. Now let's move on to the balance and stability module. We select the load case we want to use for balance and enable the case visualization if needed. We click Run Balance and Swordfish brings the vessel into equilibrium according to the defined weight and center of gravity. We can read the numerical results and, with Bake to Rhino, see the boat positioned in equilibrium. In Rhino, we now move on to stability. Here as well, we choose the mode, and in general, we recommend using the section-based mode for both balance and stability. We select the load case to analyze, define the initial and final angles, and then click Run Stability. The stability analysis starts. This is a loop that, for each angle, finds the equilibrium position of the vessel. In the background, you will see the boat progressively rotating until the selected range is completed. Once the results are available, we can visualize them using the slider, scroll through the angles, and see the attitude, the waterline, and the relative movement of the center of buoyancy and the center of gravity. Here we find all the data we may be interested in. We can visualize the righting moment graph and, of course, export everything to CSV to open it in Excel and perform more in-depth analyses. That's all. If you have questions or would like to see other use cases, let us know. Thank you.